Welcome to the Sleepy Brain Facts channel. Tonight you'll embark on a journey into one of the most ancient and quietly powerful forces shaping our world, plate tectonics. This colossal force orchestrates the rise of mountains, births oceans, and gradually forms continents on the planet we call home. It pulses beneath every landscape you have ever encountered, a patient rhythm that reshapes the Earth over millions, even billions of years. As you settle in, envision the ground beneath you not as something static, but as a living surface, carried by massive rafts of stone. Each one moves on currents far below the surface, creating a dynamic world beneath your feet. Together, we'll explore the wonders hidden beneath oceans, within mountains, and deep under the calm facade of our planet. If you find joy in these gentle explorations, I encourage you to like, subscribe, or share your thoughts below. Your engagement helps others discover this space, one sleepy soul at a time. For now, let your breath soften, allow your body to grow heavy, and let the drifting world cradle your thoughts. Let's begin. The ground beneath you is always in motion. Even when everything around you feels calm and steady, the surface beneath your feet is on a slow, silent journey. The outer shell of our planet consists of enormous slabs of solid rock that glide across a deeper layer, resembling softened stone. This motion unfolds at a pace so slow that your senses struggle to perceive it. Yet, over vast stretches of time, it profoundly transforms the very surface of our Earth. Mountains rise majestically, oceans expand, valleys emerge, and continents shift to new locations. Each landscape you recognize owes its form to this gentle, relentless movement. Picture the ground as a colossal puzzle, constantly rearranging itself, guided by powerful forces emanating from the Earth's warm interior. Though we often witness earthquakes and volcanic activity as sudden occurrences, these are merely surface manifestations of a world that is perpetually restless. The quiet reality is that Earth never truly stands still. The land you know is already journeying towards somewhere new. Earth's crust is divided into massive interlocking pieces. Rather than being a single unbroken shell, it resembles a mosaic of vast rocky sections that fit together like the surface of a cracked eggshell. These segments are called plates, each spanning enormous distances and carrying continents, oceans, or both. The edges where these plates converge are dynamic zones of constant change, where they meet, slide, separate, or submerge beneath one another. While the crust may feel solid and robust, it is thin in comparison to the layers beneath. It floats atop a softer region that gradually shifts over extended periods. As you reflect on this, consider how the world around you is alive, ever-changing, and always moving. Would you like to explore more about these incredible processes, or perhaps take a moment to rest? Imagine a world shaped by colossal plates beneath your feet. These tectonic plates play a crucial role in defining the features around you, from the depths of ocean trenches to the heights of majestic mountains. Their movements dictate where volcanoes erupt, how coastlines transform, and why certain areas experience earthquakes. When you visualize the Earth covered in these massive drifting pieces, you start to appreciate the intricate beauty of our planet as a living, dynamic entity. Tectonic plates glide at a pace comparable to the growth of your fingernails. This gentle drift may seem trivial in the grand scheme of daily life, yet over millions of years, it leads to monumental changes. Oceans can open and close, mountain ranges can rise from the ground, and islands can either collide with continents or wander across vast waters. The ability to measure this slow movement with precision is thanks to scientists who utilize advanced positioning instruments scattered across the globe. They observe the plates shifting with remarkable accuracy. Despite their gradual pace, these massive slabs harbor an immense amount of energy. Their movements influence the history of life, the flow of water, the distribution of minerals, and the very shape of our planet. Isn't it fascinating how such slow, steady changes can have such a profound impact? As you contemplate this, consider the interconnectedness of everything around you. Would you like to explore more about how these processes shape our world? In the stillness of everyday life, the Earth is engaged in a slow, patient dance. Continents move across the planet like gentle rafts, each one carrying its unique blend of mountains, forests, deserts, and cities on the backs of tectonic plates that drift through time. These continental masses, composed of lighter rock, float above the denser material of the mantle below. As you reflect on this, consider how these land masses have wandered far and wide. Some once embraced areas they now find distant, while others have come together to form supercontinents, only to drift apart again. The movement is gradual, a steady flow rather than rapid shifts. Yet, over vast spans of time, these changes can dramatically influence climate, ocean currents, and the evolution of life itself. When a continent glides over a hot spot, it may give rise to chains of volcanoes. In moments of collision, the land can crumple upward, creating majestic mountain ranges. Even the most tranquil landscapes hold the stories of these slow journeys. As you gaze at a world map, envision each landmass slowly drifting, circling, and shifting as part of an ancient narrative. Mountains emerge from the force of colliding plates, as the pressure they create can elevate entire regions of rock skyward. This dance of the earth is a profound reminder of the dynamic world we inhabit, a world that continues to evolve beneath our feet. You stand on the edge of a vast landscape, gazing at the towering mountains that have emerged over millions of years. These majestic ranges, formed by repeated compression, rise where once there were flat plains. They hold within them astonishing histories, traces of ancient oceans, deep roots buried beneath layers of rock, and minerals shaped under immense pressure. As these mountains grow, they begin to influence the world around them. They alter wind patterns, affect rainfall, and even guide the movement of glaciers. The plants and animals that inhabit their slopes evolve in response to these changes. Even though mountains seem eternal, they are in a constant state of flux, shaped by the uplift that builds them and the erosion that gradually wears them down. What you see as solid stone is a testament to the slow, powerful collision of tectonic plates that sculpt the very sky. Beneath the ocean's surface, a different kind of creation is taking place. Here, at spreading ridges, new ocean floors are born. Deep underwater, long mountain chains form as molten material from the mantle rises through cracks created by the separation of plates. As this material cools, it becomes fresh crust, steadily moving away from the ridge in opposite directions. This dynamic process leaves behind symmetrical patterns in the crust, including magnetic stripes that tell the story of Earth's magnetic history. Take a moment to reflect on this intricate dance of creation and change. It's a reminder of the forces that shape our planet, inviting you to explore further or simply rest in the wonder of it all. Imagine the ridges of the ocean floor, alive with volcanic activity that constantly rejuvenates the seafloor. Hydrothermal vents flourish in these regions, nurturing unique and stunning ecosystems that thrive in mineral-rich, heated waters. Although these ridges lie hidden beneath the depths of the ocean, they are among the most vibrant and active features on our planet. This process of creating new ocean crust is part of a continuous cycle that shapes the seafloor and drives the gradual expansion of ocean basins over geological time. Notably, the Pacific Plate is shrinking, a characteristic that sets it apart from other tectonic plates. As it dives beneath surrounding plates along arcs of subduction zones, it gradually diminishes in size. While the Pacific Plate recedes, other plates expand, forming new crust along their spreading boundaries. This intricate balance ensures that Earth's surface area remains constant, even as individual plates undergo changes in shape and size. The Pacific Plate holds significant importance in global geology, as its boundaries are sites of intense volcanic and seismic activity. Many of the world's most active volcanoes are found along its edges. As this plate continues its retreat into the mantle, new geological features emerge while older ones fade away. Take a moment to reflect on this dynamic process, where the Earth's surface is continuously reshaped, revealing the beauty and complexity of our planet. If you're curious to learn more about these geological wonders, feel free to continue exploring or take a moment to rest. The ongoing transformation of our planet reveals that tectonic plates are not static entities. They are dynamic components of a restless Earth, where creation and destruction intertwine. Earthquakes serve as a window into the hidden boundaries of these plates. While it may be challenging to observe the plates directly, their edges announce their presence through the patterns of earthquakes they create. As plates shift, grind, or collide, stress accumulates along faults until the rocks ultimately slip. This sudden movement generates waves that ripple through the ground, which scientists can capture with advanced instruments. By mapping the locations of these earthquakes, researchers can outline the known plates and even uncover new or unexpected boundaries. And these seismic maps reveal intricate structures deep beneath the surface, including significant faults in regions where slabs are descending into the mantle. Earthquakes provide one of the clearest insights into the dynamic nature of our planet. While these events can be unsettling, they also offer valuable information about the Earth's workings. Each tremor serves as a reminder that the ground is alive with constant motion, and that the forces shaping our planet operate on scales far beyond any single lifetime. The deepest trenches emerge where plates dive downward, illustrating the powerful interactions at play beneath our feet. In certain remarkable regions of our planet, the ocean floor plunges into deep chasms, the most profound on Earth. These trenches are formed through a process called subduction, where one tectonic plate bends and sinks beneath another. This bending creates a long, shadowy depression that descends into the mantle. Despite the immense pressures that would crush most life forms, unique ecosystems thrive in these depths. Here, rocks undergo transformation due to heat, pressure, and the movement of chemically rich fluids. Above these trenches, arcs of volcanoes often rise on the overriding plate, showcasing the incredible power of these descending slabs to melt materials deep within the Earth. The trenches serve as portals, returning crust back to the interior and perpetuating a cycle that has been ongoing for ages. They are among the most remote and enigmatic places on Earth, concealing worlds we have only begun to uncover. Meanwhile, the Himalayas continue to rise, growing taller each year. This tallest mountain range is still in the process of formation as the landmass of India collides with the continent of Asia, pushing the ground upward. The two plates remain locked in a slow yet powerful embrace, a testament to the dynamic nature of our planet. As you gaze upon the majestic Himalayas, you witness a testament to the immense forces of nature. The rocks here tell a story of compression, folding, and uplift, revealing the mountain's ongoing rise. These towering giants shape the regional climate, influencing monsoon patterns and capturing moisture carried by the winds. Their glaciers nourish major rivers that sustain millions of lives. Despite the relentless erosion that carves valleys and wears down peaks, the power of this geological collision ensures that the range continues to ascend over vast stretches of time. Standing before these mountains, you can feel the weight of geological history still unfolding. The Himalayas are a living testament to the incredible force of plate tectonics, which sculpts our world in profound ways. Consider this: new oceans can rupture within continents. Over eons, land can stretch and thin, leading to the formation of great cracks deep within its core. When this stretching intensifies, the land gradually sinks, creating long rift valleys that grow wider and deeper. Over millions of years, these rifts can fill with water, evolving into new ocean basins. This remarkable process reveals that oceans are not merely found between continents. They can emerge from the very breaking of the continents themselves. As the crust pulls apart, magma rises into the gaps, solidifying into fresh rock, marking the dawn of a new spreading ridge. Take a moment to reflect on this incredible journey of our planet. You are part of this unfolding story, and there is so much more to explore. Would you like to continue this journey, or perhaps take a moment to rest? Imagine a world where subtle fractures in the land can evolve into vast ocean floors, complete with mid-ocean ridges, volcanic activity, and intricate coastlines. Scientists delve into regions like the East African Rift to catch a glimpse of how a young ocean might emerge. The notion that a dormant continent can cradle a nascent ocean within its seams serves as a reminder that our planet is in constant flux, even in areas that seem most stable. Consider how entire land masses can tear themselves apart. Although continents may appear permanent and unyielding, deep geological forces can stretch and weaken them until they ultimately break into separate pieces. This process unfolds when mantle currents exert pressure on the base of the crust, or when surrounding tectonic plates shift, creating tension. As the land stretches, it fractures into a mosaic of faults that gradually drift apart. Lakes often emerge along these faults as the land sinks, while volcanic activity may rise where the crust thins enough for magma to escape to the surface. Over time, this stretching can become so pronounced that seawater floods in, forming a new coastline. This is how vast regions that were once connected can drift thousands of miles apart. Geologists meticulously trace the scars of ancient continental splits by examining matching rock layers and fossil evidence found along distant shores. This exploration reveals the intricate story of our planet's ever-changing landscape. So, as you reflect on these transformations, consider the wonders of geological processes shaping the world beneath your feet. These separations show you that continents are not fixed entities. They are vibrant landscapes shaped by powerful forces over vast stretches of time. One of the most significant processes at work is subduction, where a tectonic plate sinks into the Earth's interior. This descent pulls surface rock into an environment of extreme heat and pressure. As the slab moves downward, it releases water and other materials that have traveled from the ocean floor. These elements help to melt parts of the overlying mantle, creating magma that can rise to feed volcanoes. At the same time, the slab continues its journey deeper into the earth, gradually transforming into new types of rock as it encounters varying temperatures and pressures. Over millions of years, this recycled material becomes part of the mantle, which plays a crucial role in driving plate motion from below. Without subduction, old crust would pile up on the surface, and our planet would struggle to renew and reinvent itself. This recycling of the crust is vital for keeping Earth dynamic and is one of the key forces behind its ongoing evolution. You can trace the paths of moving plates through the chains of volcanoes they create. Across the surface of our planet, you can find extraordinary lines of volcanoes that illustrate the slow migration of tectonic plates. These volcanic chains emerge when a plate glides over a stationary hotspot deep within the Earth's mantle. As the plate moves, magma rises through the crust at various points along its path, giving rise to a series of volcanoes in a lengthy progression. As older volcanoes drift away from the hotspot, they become extinct, while new ones form above the ascending plume of magma. This continuous process results in chains of islands or mountain peaks, each one documenting the direction and speed of the plate's movement. By examining these volcanic chains, scientists are able to piece together the history of a plate's journey over immense spans of time. Some of these volcanoes rise from the ocean floor, forming entire island groups, while others create long, majestic mountain ridges on land. Each chain serves as a natural timeline, etched in stone, revealing how continents and oceans have shifted throughout the ages. One of the most notable examples is the Ring of Fire, a global necklace of volcanoes that encircles the Pacific Ocean. This expansive region is home to the majority of the Earth's active volcanoes, forming a vast chain shaped by the boundaries of the Pacific Plate. As you reflect on this incredible geological phenomenon, consider how it connects to the very fabric of our planet's history. Would you like to explore more about the wonders of our Earth? Imagine standing at the edge of a vast dynamic landscape. Here, tectonic plates dive beneath one another, generating intense heat and melting rock that fuels frequent volcanic eruptions. This area, known as the Ring of Fire, is also one of the most earthquake-prone regions on Earth. In these subduction zones, enormous amounts of energy are stored and then released, creating a powerful natural cycle. The volcanoes in this region vary greatly. Some are towering stratovolcanoes that command the landscape, while others are submerged peaks hidden beneath the ocean's waves. These volcanic formations have significantly influenced human history, enriching soils, forming new islands, and sometimes unleashing devastating eruptions. The Ring of Fire serves as a vivid reminder of the ever-changing nature of our planet. The edges of tectonic plates are among the most dynamic areas on Earth, constantly reshaped by forces that rise from deep within its interior. Beyond the boundaries of these plates, we find hotspots, extraordinary phenomena that create islands far from tectonic edges. While most volcanoes form where plates collide or pull apart, hotspots are unique. These deep-rooted plumes of rising heat can penetrate the Earth's crust in locations distant from any plate boundary. When a hotspot reaches the surface, it can give rise to volcanoes that build islands in the middle of oceans or erupt within continents, far from the familiar tectonic interactions. Hotspots are believed to tap into regions of the mantle that are heated enough to push molten rock upward, creating a fascinating interplay between the Earth's interior and its surface. As you reflect on this, consider the power and mystery of these geological processes. They remind us of the incredible forces at work beneath our feet, shaping the world we inhabit. If you're curious to learn more, feel free to continue exploring or take a moment to rest and absorb this captivating information. Imagine the powerful eruptions of volcanoes, creating chains that serve as natural markers of a tectonic plate's movement. Some hotspots remain active for tens of millions of years, forming expansive volcanic plateaus or islands that drift away as the plate continues its journey. When you see islands in the midst of vast oceanic plates, you witness one of the most compelling clues that these hotspots are deep, dynamic features of Earth's interior. Take the Hawaiian Islands, for example. They illustrate how a tectonic plate glides over a stationary source of intense heat. Beneath the Pacific plate, a plume channels hot material upward, fueling volcanic activity at the surface. As the plate shifts over this plume, new islands emerge directly above the hotspot, while older islands gradually drift away and weather over time. Each island in this chain tells a story of a different moment in the plate's passage across the mantle plume. The youngest island, perched above the hotspot, remains volcanically active. In contrast, the islands further along the chain grow older and more eroded. Beneath the ocean floor, extinct volcanic mountains extend this chain for an immense distance, preserving a geological record that stretches far beyond what we can see on the surface. As you reflect on this incredible journey of the Earth's plates, consider how each island represents not just a location, but a chapter in the ongoing story of our planet. Would you like to explore more about these fascinating geological processes? Or perhaps take a moment to ponder the wonders of nature? Imagine a captivating parade of land masses moving slowly across the vast expanse of the Pacific Ocean. This gradual migration of tectonic plates gives rise to entire chains of islands, each one a testament to the dynamic forces of our planet. You may wonder why continents rise above the oceans. The answer lies in the composition of the Earth's crust. Continental crust, made of lighter materials, floats higher on the mantle compared to the denser oceanic crust below. This buoyancy creates a fascinating contrast. While the continents stand tall, the ocean basins form deep depressions. The continental crust is not only thicker, but also rich in lighter minerals, making it less dense than the darker volcanic rock that composes the oceanic crust. Because of this, continents act like vast floating platforms, resisting the downward push that might affect them. When tectonic plates collide, the result is often a dramatic shift. The lighter continental blocks tend to rise, while the heavier oceanic plates sink. This interplay shapes the structure of the Earth's surface and drives the evolution of our planet over time. As continents drift, they carry this unique buoyancy with them, floating like massive geological rafts above the oceans. This natural flotation effect has a remarkable side effect. It helps preserve ancient crust. Therefore, continents are home to some of the oldest rocks on Earth. Within these rocks, you can find evidence of ancient magnetism, a reminder of the planet's history etched in stone. As you reflect on this, consider the intricate dance of the Earth's plates and the stories they tell through the ages. Would you like to continue exploring this fascinating world? Or perhaps take a moment to pause and reflect? As molten rock cools, whether at the surface or beneath the ocean, it captures the minerals within it, locking in the direction of Earth's magnetic field at that precise moment. These magnetic signatures are preserved in the rock, even as tectonic plates shift across the globe. By analyzing these magnetic traces, scientists can uncover where rocks initially formed and how far they have journeyed. This process enables researchers to reconstruct the ancient positions of continents with impressive accuracy. On the ocean floor, the magnetic record is particularly striking. Stripes of rock alternate in polarity, reflecting the long-term flips of Earth's magnetic field. These stripes create matching patterns on either side of spreading ridges, providing a vivid timeline of plate movement. The frozen magnetism within the Earth's crust acts like a silent compass, revealing clues about how continents have wandered and how the planet's magnetic field has changed over eons. The continents have undergone cycles of assembly and separation, many times, long before the landscapes we recognize today took shape. They have united into vast supercontinents, only to drift apart again. This ongoing cycle is driven by the gradual movement of tectonic plates, which bring land masses together through collisions and then separate them as new oceans emerge. Isn't it fascinating to consider how our planet's history is etched in the very rocks beneath our feet? Imagine a time when each supercontinent created a unique world, complete with its own climate, ocean currents, and ecosystems. Over millions of years, heat builds beneath these massive land masses, gradually weakening their foundations. This process leads to cracks and splits, sending fragments on new journeys across the globe. Sometimes, these pieces join together again, forming new supercontinents in future ages. As you explore this ancient history, you find evidence of these long-lost unions in matching rock formations, similar mountain ranges, and shared fossils found on continents now separated by vast oceans. The ongoing assembly and breakup of supercontinents reveal a constantly changing Earth, shaped by cycles that far exceed human history. When you hear the name Pangaea, you might envision it as the first and only instance when all continents were united. However, the story of our planet goes much deeper. Throughout its extensive timeline, Earth has seen several massive supercontinents rise and fall, long before Pangaea ever existed. Each of these colossal landmasses brought together nearly all of Earth's land, creating ancient worlds with climates strikingly different from those we know today. As you reflect on this dynamic history, consider how these transformations shape not only our planet, but also our understanding of its past. You are invited to continue this journey of discovery, or take a moment to rest and absorb the wonders of our ever-evolving Earth. Imagine rivers winding through vast interior plains, where coastlines are mere whispers on the horizon. The winds carry moisture across countless miles of uninterrupted land, creating a tapestry of nature's design. Before the era of Pangaea, ancient supercontinents like Rodinia and Nuna emerged, their names echoing like distant memories in the annals of geology. They rose, flourished for millions of years, and eventually fragmented as the heat beneath them grew too intense. These pieces drifted across the planet, only to collide once more, giving rise to new supercontinents in ages yet to come. When scientists piece together these ancient landscapes, they reveal how the Earth's continents are part of a recurring cycle of gathering and separation. The world we inhabit is just the latest chapter in a story that has unfolded countless times. It's intriguing to consider that one day Earth might form another supercontinent. The continents around you are still in motion, their slow journeys hinting at a future where all land masses might once again unite. This gradual drift of tectonic plates is imperceptible within a human lifetime, yet it continuously reshapes our globe. Some researchers even imagine a future where the Americas and Asia collide, forging a new connection. Isn't it fascinating to think about the Earth's ever-evolving narrative? As you reflect on this, allow yourself to ponder the vastness of time and the cycles that define our planet. Imagine a world where Africa drifts northward, closing the Mediterranean and merging with Europe. Some even envision a new supercontinent emerging near the equator or in the northern regions of our planet. While we can't predict the exact path the continents will take, one idea remains constant: the Earth's surface is not fixed. It undergoes a long cycle, driven by heat within the mantle that pushes and pulls the continents in repeating patterns. Consider the implications of a future supercontinent. Such a shift would transform climate, ocean circulation, and the entire tapestry of life on Earth. The subtle movements we hardly notice today are already shaping the world that future generations will inherit. This distant possibility serves as a reminder that even continents are temporary forms on an ever-changing planet. Beneath the Atlantic Ocean lies the Mid-Atlantic Ridge, an immense underwater mountain chain that stretches from the far south to the icy northern seas. This ridge marks the boundary where two tectonic plates gradually drift apart. As they separate, molten material from deep within the Earth rises into the gap, cooling to create new ocean floor. Take a moment to reflect on this dynamic world. The shifting of continents is a slow dance, a reminder of the continuous change that shapes our existence. Wouldn't you agree that it's fascinating to think about the world's future? As you delve into the mysteries of our planet, consider how a simple process unfolds over vast stretches of time. This ongoing movement gradually widens the Atlantic Ocean, pulling the continents further apart as fresh crust emerges from the depths of the ridge. Scientists have employed sonar to map this ridge, revealing that it is not just a smooth line, but a complex tapestry of valleys, volcanic peaks, and fracture zones. Beneath the surface, hydrothermal vents release superheated water, rich in minerals, nurturing unique life forms in the complete darkness of the ocean floor. The Mid-Atlantic Ridge stands as one of the longest mountain systems on Earth, quietly reshaping our planet with each passing moment. Iceland, a land that sits atop this ridge, offers a rare glimpse into this dynamic process. It is one of the few places where a major spreading ridge rises above sea level. Here, you can witness the boundary between the North American and Eurasian plates, which are slowly drifting apart. Imagine standing in locations where the ground visibly cracks open, where valleys expand year after year, and new crust forms as molten rock rises from below. This extraordinary geological setting is what fuels Iceland's remarkable volcanic activity. As you reflect on these wonders, you might feel a sense of connection to the powerful forces shaping our world. Would you like to explore more about how these processes affect our planet? Imagine standing on an island that sits directly above a place where the Earth reveals its inner heat and magma. Iceland, with its dramatic landscapes of lush fields, geysers, and steaming vents, serves as a vivid reminder of the powerful forces at work beneath the surface. Here, the land is slowly expanding as new material fills the gaps between separating tectonic plates. It's a living laboratory of plate tectonics, providing a rare glimpse into a process that typically unfolds far beneath the oceans. Now shift your focus to Africa, where the East African Rift is gradually pulling the land apart. This rift stretches for thousands of miles, characterized by deep valleys, towering escarpments, and volcanoes that emerge from regions where the crust is thinning. In many of the low-lying areas formed by this stretching, lakes have taken shape, some of which are among the deepest on our planet. The rift is not merely a single crack in the ground, it's a complex network of faults and uplifted regions, sculpted by the forces pushing from below. Scientists speculate that in the distant future, this rift may widen enough for ocean waters to flood in, potentially creating a new landmass that separates Eastern Africa from the rest of the continent. Additionally, this area is rich in fossil sites, preserving evidence of early human ancestors who once roamed its ever-changing landscapes. As you reflect on these incredible geological processes, consider how they shape not just the land, but also the story of life itself. Would you like to continue exploring these wonders, or perhaps take a moment to rest? As you observe the slow transformation of Africa, you witness how continents evolve from within, reshaping themselves through profound geological processes that unfold over timescales far beyond our daily lives. The Red Sea, a nascent ocean in the making, lies nestled between Africa and the Arabian Peninsula. This long, narrow stretch of water offers a fascinating glimpse into the beginnings of ocean formation. Here, the African and Arabian tectonic plates are gradually pulling apart, creating a spreading zone. As the land separates, magma rises to fill the void, forming new crust that pushes the edges further apart over time. This process echoes the early development of significant oceans, like the Atlantic. Although the Red Sea is still considered young in geological terms, it already displays many characteristics of a mature ocean. It boasts deep basins, active volcanic regions, and hydrothermal systems hidden beneath its surface. Over vast periods, the Red Sea will continue to widen, eventually evolving into a full-fledged ocean, complete with its own central ridge. As you stand on its shores, you find yourself quietly witnessing the birth of a future ocean basin. The Red Sea serves as a reminder that even today, our planet is actively creating new oceans in real time. Meanwhile, Australia is slowly drifting northward toward Asia, a testament to the ever-changing nature of our world. Australia is not a static landmass. It is in constant motion, slowly drifting northward on the Indo-Australian plate as it journeys toward Asia. Advanced positioning instruments spread across the continent capture this subtle yet significant movement each year. Over millions of years, this gradual shift will bring Australia closer to the islands and landmasses of Southeast Asia. Geological models suggest that as these two regions interact more directly, we may witness mountain building and changes in ocean circulation. Australia's northward movement is part of a broader pattern of plate tectonics that shapes the entire Pacific region. The continent's unique wildlife and ecosystems, which have evolved in relative isolation, could soon face new environments in the distant future. Isn't it fascinating to think that such a vast continent can slide across the Earth's surface without us noticing in our daily lives? Just as California is inching toward Alaska along a fault line, the western edge of North America is defined by a complex network of faults that delineate the boundary between the Pacific and North American plates. As you reflect on this slow yet powerful movement beneath our feet, consider the quiet forces of nature that shape our world. Would you like to continue exploring these geological wonders, or perhaps take a moment to rest and ponder? Imagine the San Andreas Fault, the most renowned of its kind, where tectonic plates slide horizontally past one another. This slow movement gradually drags parts of California toward Alaska over vast geological timescales. Yet this sliding isn't a smooth process. Instead, tension builds up along locked sections of the fault, only to be released in sudden jolts that we recognize as earthquakes. As you observe the landscape along the fault, you can see the evidence of this ongoing motion. Streams are offset, valleys twist, and even mountains have shifted their positions over time. Scientists keep a close watch on these faults, keen to understand how stress accumulates and how the land transforms. Although the movement is measured in tiny increments each year, the cumulative effect is staggering. Entire regions are gradually migrating northward, driven by forces deep within the Earth. Some tectonic plates have completely vanished, descending into the depths of the mantle. What we see on the surface today is merely a snapshot of a world in constant flux. Many plates that once defined ancient oceans and continents have disappeared, carried downward through a long history of subduction. Their remnants may still linger far beneath us, preserved as distorted slabs detected through seismic imaging. Isn't it fascinating to think about the dynamic forces shaping our planet? As you reflect on this, consider how each movement contributes to the ever-evolving landscape around you. If you feel inclined, take a moment to continue exploring or rest in this wonder of nature. Imagine a world where ancient plates once defined the boundaries of our climate, ocean currents, and the very distribution of life itself. Over time, these plates have sunk deeper, becoming part of the convecting mantle that drives the motion of tectonic plates. Geologists have meticulously pieced together their stories, using clues found in mountain ranges, island arcs, and the magnetic patterns embedded in rocks. These remnants tell us where vast oceans once existed and how continents have shifted over millennia, sometimes colliding, sometimes drifting apart. The disappearance of entire plates serves as a reminder that nothing on Earth's surface remains unchanged. Even the strongest structures of solid rock eventually return to the depths from which they originated. Take the Juan de Fuca plate, for instance. It is slowly vanishing beneath North America. Off the western coast of the United States lies the Juan de Fuca plate, a small yet significant player in this grand geological narrative. It is steadily sliding beneath the North American plate in a region where the ocean floor is consumed by the mantle. This subduction zone fuels volcanic activity across the Cascade Range, home to iconic peaks like Mount Rainier and Mount St. Helens. As this plate descends, it carries with it oceanic crust rich in water. As it plunges deeper, the heat and pressure release fluids that contribute to the formation of magma. This intricate dance between plates is a reminder of the dynamic and ever-changing nature of our planet. As you reflect on this, consider how these geological processes shape not only the landscape, but also the life that thrives upon it. Would you like to continue exploring this fascinating world, or perhaps take a moment to rest? Imagine the dance of magma as it rises to the surface, fueling eruptions that paint the landscape. As the Juan de Fuca plate descends deeper into the mantle, it becomes compressed, heated, and transformed. Over vast stretches of time, this plate will fade away, leaving only subtle geological traces behind. This gradual disappearance is a vital part of the ongoing cycle that reshapes the North American margin, renewing the crust through subduction and volcanic activity. Beneath the continents and oceans, far below the shifting layers of rock, the remnants of ancient tectonic plates lie buried. These long-lost slabs sank into the mantle, becoming cold, dense regions suspended within the warmer, flowing rock surrounding them. Scientists uncover these ghostly remnants by analyzing the behavior of seismic waves as they travel through the Earth. These waves shift in speed and pattern, revealing the hidden shapes of structures deep within the planet. Some of these buried slabs may stretch hundreds of miles, warped and folded by the immense pressures of the Earth's interior. They carry the stories of vanished oceans, forgotten boundaries, and lost land masses. As you reflect on this geological narrative, consider the profound history that lies beneath our feet, waiting to be discovered. Would you like to continue exploring this fascinating world, or perhaps take a moment to rest? Every sunken plate tells a story, representing a chapter in Earth's ancient history that ended millions of years ago. As the surface transformed, these relics sank from view, yet their presence reminds us that nothing truly vanishes. Instead, it returns to the depths, becoming part of the planet's enduring memory, patiently waiting for scientists to uncover its narrative. Beneath the crust lies the mantle, a realm that may appear still and solid at first glance. However, it behaves like a slowly shifting sea over geological time. Composed of rock that feels rigid in the short term, the mantle is also warm and under pressure, allowing it to flow gradually over immense stretches of time. This flow is so slow that an inch of movement can take years, yet its cumulative effect drives the motion of continents and the formation of mountains and oceans. Within the mantle, convection circulates heat from the deep interior toward the surface, moving materials in cycles that span millions of years. As currents push through, the rock deforms subtly, folding and stretching in response. This remarkable blend of solid strength and gentle fluidity lays the groundwork for plate tectonics, shaping the very world we inhabit. As you reflect on these processes, consider how they connect us to the Earth's history. Would you like to explore more about our planet's incredible story? Or perhaps take a moment to rest? When you picture the mantle as a gentle, ancient current flowing beneath the Earth's crust, you start to understand how our planet constantly transforms from within. The heat generated in Earth's interior fuels the movement of tectonic plates. This immense motion of continents and oceans is ultimately driven by the warmth radiating from deep within the planet. This heat originates from the decay of radioactive elements, the residual warmth from Earth's formation, and the gradual release of energy trapped in the mantle and core. As heat rises through the layers, it creates convection currents that move materials in large looping patterns. These slow movements push and pull the plates above, guiding the drift of entire continents. This flow isn't abrupt, it is persistent, patient, and constant. Over millions of years, the rising warm material and sinking cooler material form a hidden engine that shapes the surface of our world. Without this deep internal heat, the crust would remain motionless. Oceans would neither open nor close, and mountains would not rise. The landscapes we recognize owe their existence to energy that has been flowing from the heart of the planet since the earliest days of its history. Imagine the mantle stirring like a slow, simmering soup, quietly crafting the world you see today. Imagine a vast underground realm where heat rises and cooler material sinks, creating gentle currents that churn through solid rock. This is the mantle, a layer of the earth that, despite its solidity, behaves like a slow-moving fluid under immense pressure and temperature. Over millions of years, these currents evolve, driving the movement of tectonic plates at the surface. Warm regions of the mantle rise, spreading out beneath the Earth's crust, only to cool and sink back down in a continuous cycle. The speed and shape of these currents change based on the mantle's structure and the thermal energy that flows upward from below. As they move, they can lift parts of the crust, thin other areas, and create zones of tension or compression. These dynamic flows are also responsible for volcanic hotspots and deep plumes, generating activity far from the boundaries of tectonic plates. When scientists simulate these currents, they visualize a planet alive with a slow, sweeping motion, hidden beneath a seemingly solid surface. Among the forces at play, slab pull stands out as a significant factor in plate movement. This powerful downward force is created by subducting slabs, pulling the plates along with it. The mantle's stirring is indeed one of the great engines driving Earth's geological processes. Take a moment to reflect on this intricate dance beneath our feet, a force that shapes our planet in ways we often overlook. Imagine a dense oceanic plate slowly sinking into the mantle beneath it. Its weight acts like an anchor, pulling the rest of the plate along with it. This movement accelerates the plate's journey across the Earth's surface, guiding its direction and speed. As the sinking slab drags cooler material downward, it establishes convection patterns that sustain the entire tectonic system. You might wonder how this process influences the world around us. Slab pull plays a crucial role in forming trenches, volcanic arcs, and even the motion of continents connected to the plate. Scientists who study plate speeds often discover that the fastest moving plates are those with large subducting edges, highlighting the significance of this force. The strength of slab pull demonstrates the powerful influence of gravity in shaping our planet. As these slabs descend, they help recycle old crust back into the mantle, maintaining the ongoing geological activity that characterizes Earth. Alongside this process, ridge push also drives continents across the globe. At spreading ridges, where new crust forms, rising magma pushes the surrounding plates outward. As this hot material cools and becomes part of the ocean floor, it sits slightly higher than the older, cooler crust found further away from the ridge. This height difference creates a gentle slope, causing the newly formed crust to slide away and push the plates along with it. Take a moment to reflect on this intricate dance of tectonic forces. The Earth's surface is alive with movement, and each process plays its part in the grand tapestry of our planet's geology. You can choose to continue exploring this fascinating world, or take a moment to rest and absorb what you've learned. Ridge push may not be the most powerful force driving plate motion, yet it exerts a steady and significant pressure that plays a crucial role in moving continents and oceans across our planet. This outward expansion represents a delicate balance between creation and destruction in the realm of plate tectonics. As new crust forms at mid-ocean ridges, older crust is gradually consumed at subduction zones. Ridge push ensures that these spreading centers consistently provide the momentum needed to keep the plates in motion. Over millions of years, this slow but persistent outward pressure can shift continents thousands of miles, transforming coastlines, altering climate patterns, and reshaping the global arrangement of land and sea. The lithosphere, the outer shell of our Earth, floats on a layer known as the asthenosphere. This lithosphere comprises both the crust and the uppermost part of the mantle. It is rigid and strong, forming the plates that traverse the Earth's surface. Beneath the lithosphere lies the asthenosphere, a warmer and more flexible layer that behaves like a soft, deformable substance over extended periods. Imagine the lithosphere resting on this layer, much like a raft floating on a gently flowing current. Although the asthenosphere is still solid rock, the heat and pressure it experiences allow it to flow slowly, enabling the lithosphere to glide gracefully above it. Isn't it fascinating how these forces shape our world? As you reflect on this, consider the profound impact of these geological processes on our environment. If you wish, take a moment to absorb this knowledge, or let it inspire further curiosity about the wonders of our planet. The layers of our planet are intricately connected, influencing everything from plate movement to the formation of earthquakes in volcanic regions. You can think of the lithosphere as a rigid shell, while the underlying asthenosphere acts like a warm, pliable layer. This contrast is crucial for the process of plate tectonics. Without the asthenosphere, the crust would remain locked in place, unable to shift or reshape the Earth's surface. Imagine the lithosphere floating on this soft layer, creating a foundation for a constantly evolving planet. The asthenosphere isn't molten rock, but rather it behaves like warm plastic, allowing it to deform over long periods. This softening effect is what enables the tectonic plates above to move, bend, and interact with each other. As the asthenosphere responds to various stresses, it flows very slowly, redistributing material over millions of years. This slow movement allows mountain ranges to rise, ocean basins to expand, and rifts to open as the plates adjust to forces from below. Additionally, the asthenosphere transmits energy from deep convection currents, which guide the motion of these tectonic plates. Scientists have discovered that seismic waves travel differently through this warm layer, compared to the cooler, more rigid lithosphere above. As you reflect on this dynamic system, consider how these processes shape our world, creating the landscapes we see today. If you find this intriguing, take a moment to explore further, or simply embrace the wonder of our planet's ever-changing nature. Imagine a layer deep within the Earth, known as the asthenosphere. Its remarkable ability to function both as a solid and a slowly flowing medium makes it one of the most significant regions beneath our feet. Did you know that Earth's interior contains more water than all the oceans combined? Far within the mantle, beyond any ocean's reach, lies water trapped within minerals. This hidden water may surpass the total volume of all surface oceans. However, it isn't liquid in the way we typically think. Instead, it's bound within the crystal structures of minerals formed under immense pressure. As oceanic crust sinks into the mantle, it carries with it rocks rich in water. Under the influence of heat and pressure, these minerals transform, storing water in unique ways. This process allows the deep interior to serve as a vast reservoir. Over time, this water can influence various geological processes, including mantle melting, volcanic activity, and the buoyancy of rising plumes. When the mantle brings this water back to the surface through volcanic eruptions, it plays a crucial role in the long-term cycling of water between the Earth's interior and its crust. This deep reservoir challenges our understanding, revealing that the story of Earth's water is much more intricate than just the oceans. The planet's interior holds secrets that reshape our perception of where water can exist, even in solid rock. As you reflect on this, consider the profound connections between the Earth's layers and the water that sustains life on the surface. Would you like to continue exploring this fascinating topic, or perhaps take a moment to pause and absorb this knowledge? Imagine the powerful journey of subducting plates as they carry water deep into the Earth. When an oceanic plate sinks beneath another, it brings along water that has seeped into cracks and minerals on the ocean floor. As this plate descends, the trapped water becomes locked within the rocks, venturing into the high-pressure environment of the mantle. This movement of water triggers processes that significantly alter the chemistry and behavior of the Earth's interior. At certain depths, minerals release some of this water, which aids in melting the surrounding mantle and generating magma. This is one reason why volcanic arcs often form above subduction zones. Even deeper, other minerals capture water and store it within their structures, creating hidden reservoirs far beneath our feet. The downward journey of water also softens rocks, influencing how these slabs bend and contributing to the long-term cycling of materials between the surface and the deep interior. Subduction is not merely the sinking of cold crust. It acts as a conveyor that transports water and minerals into the planet's heart. This water plays a crucial role in magma formation deep beneath volcanoes. When water is carried downward by a subducting plate, it creates something truly extraordinary within the mantle. As you reflect on this remarkable process, consider how interconnected our planet's systems truly are. As the massive slab descends, it heats up, releasing water trapped within its minerals into the surrounding rock. This water lowers the melting point of the mantle, allowing it to partially melt at depths far beyond where surface water could ever reach. The resulting molten material rises, lighter than the solid rock around it. As it ascends, it collects in chambers, evolving and mixing, building up pressure that eventually fuels volcanic activity on the surface. This water-driven melting process is crucial for many of the volcanoes found along subduction zones. The presence of water also alters the chemistry of the magma, contributing to the explosive nature of many eruptions in these areas. This reveals that Earth's water cycle extends far beyond oceans, clouds, and rain. Water moves quietly through the depths, playing a vital role in forming new crust and renewing landscapes shaped by volcanic forces. Some volcanoes are positioned directly above these descending slabs. In numerous mountain ranges and island arcs, chains of volcanoes rise in a nearly perfect line above the point where an oceanic plate bends downward beneath a continent or another oceanic plate. This intricate dance of geology reminds us of the profound connections between water, rock, and the dynamic planet we call home. Would you like to explore more about this fascinating process, or perhaps take a moment to reflect? Volcanoes emerge from a fascinating process. As oceanic plates sink into the earth, they carry water and minerals deep into the mantle. This journey helps to generate magma, which then rises to the surface. You might find it intriguing that the alignment between the descending slab and the overlying volcanoes is so precise that geologists can map the shape of the slab by examining the location and chemistry of these volcanoes. In certain areas, the slab descends steeply, causing volcanoes to be situated close to the trench. In other locations, the slab dips more gently, resulting in volcanoes that are positioned further inland. The depth at which this slab releases water can significantly influence the type of volcanic activity that occurs. These volcanoes often harbor vast reservoirs of magma, evolving over long periods before they erupt. They serve as a reminder that the Earth's surface is intricately linked to its deep interior through pathways that transport heat, minerals, and molten rock from regions far beyond our everyday experience. As oceanic crust sinks beneath another plate, it encounters immense pressure, transforming the subducting rocks. This pressure is so intense that it alters their structure and composition. Minerals rearrange themselves into new forms capable of withstanding extreme conditions, creating unique rocks that exist only deep within our planet. Isn't it remarkable to think about the forces at play beneath our feet? If you feel inspired, take a moment to reflect on this connection between the surface and the depths of the Earth. Imagine the ocean floor, where basalts quietly rest, waiting to embark on a remarkable transformation. As they sink deeper, they evolve into dense minerals like eclogite, which play a crucial role in pulling tectonic slabs downward due to their added weight. Water trapped within the subducting crust initiates further changes in mineral structure, reshaping the very essence of the rock. As these rocks descend, temperatures rise, and they undergo additional transformations, documenting a journey that few samples manage to endure. Occasionally, slices of these metamorphosed rocks are thrust back to the surface through mountain-building processes. When these rocks emerge in exposed terrains, they become rare windows into the depths of the Earth. They reveal the immense pressures and temperatures that sculpt our planet's interior, serving as a reminder that mountains can lift materials from astonishing depths, bringing the tales of vanished slabs into the light. Consider the formation of diamonds, born under extreme conditions at plate boundaries. While they may appear delicate and sparkling on the surface, their creation is rooted in the brutal realities of the mantle. Here, immense pressures and high temperatures work together to transform carbon atoms into rigid crystalline structures. If you find yourself intrigued by these geological wonders, take a moment to reflect on the stories they tell about our planet's hidden depths. Imagine the journey of a diamond emerging from depths far below the Earth's crust. These precious gems often originate in regions where ancient tectonic slabs have descended or where continents have thickened due to collisions. The carbon that eventually transforms into a diamond may come from the mantle itself or from materials carried downward by subducting plates. Over time, remarkable volcanic eruptions, known as kimberlite events, propel these crystals to the surface. They travel at incredible speeds, preserving their unique structures before they can revert to ordinary carbon. Inside these diamonds, you might find inclusions of minerals that only form under extreme conditions, providing fascinating insights into the composition of the deep earth. Some diamonds even hold tiny pockets of water or gases, revealing secrets about ancient mantle environments. Each diamond serves as a geological time capsule, shaped by immense pressure, heat, and the intricate history of tectonic movement. Now, consider the ocean floor. It tells a surprising tale. While the continents boast rocks that date back billions of years, the ocean floor presents a much younger narrative. This is due to the continuous creation of new crust at spreading ridges and its destruction at subduction zones. Consequently, the oldest seafloor we find today is merely a small fraction of Earth's vast history. As you reflect on these incredible processes, you might feel a sense of wonder about the stories hidden within both diamonds and the ocean floor. Each holds clues to our planet's past, inviting you to explore further or take a moment to appreciate the mysteries of our Earth. You might find it fascinating to learn about the oceanic crust and its role in the Earth's dynamic surface. The older oceanic crust has been absorbed into the mantle, leaving behind a younger seafloor that serves as a valuable record for scientists. This youthful nature aids in tracking plate movements, as the magnetic patterns and ages of the rocks create a clear timeline of spreading and subduction. Isn't it remarkable how efficiently the Earth recycles its surface? While continents accumulate layers of history and grow older, the ocean floor experiences a continuous cycle of creation and destruction. This rapid turnover is vital for plate tectonics, maintaining a delicate balance between these opposing forces. Continents, on the other hand, hold billions of years of ancient crust. Their thick and buoyant nature allows them to persist much longer without being recycled into the mantle. This buoyancy acts as a shield for ancient rocks, which tell the story of some of the earliest chapters in Earth's history. Deep within the interiors of continents lie cratons, stable regions made up of extremely old rocks that have withstood numerous tectonic events. These ancient fragments hold valuable minerals that formed when the planet was still young, long before complex life emerged. By examining these rocks, scientists are able to uncover evidence of early atmospheres and primitive tectonic processes. As you reflect on this fascinating interplay between the oceanic and continental crusts, consider how each contributes to our understanding of Earth's history. If you wish to learn more, feel free to continue exploring this captivating topic. As you walk upon the surfaces of our planet, consider the layers beneath your feet. These layers tell stories that span eons, recording volcanic eruptions, the rise of mountains, and the shifting of continents. This preserved history allows you to trace Earth's evolution from a young, fiery world to the rich and diverse planet we inhabit today. The continents serve as vast archives, holding memories that the oceans gradually wash away. The edges of tectonic plates are not static. They can flip and change direction. Over long geological timescales, a region that once experienced the spreading of plates may later become the site of subduction, where one plate sinks beneath another. A margin that once pulled apart may transform into a zone of collision. These transformations occur when forces within the Earth's mantle shift or when the interactions between plates evolve. You can observe evidence of these changes in areas where ancient spreading centers have been compressed into mountain ranges, or where subduction zones have reversed their direction. Sometimes the movement of one plate can pull another into a new configuration, altering the stress patterns across an entire region. These transitions highlight that plate boundaries are dynamic features, shaped by the deeper currents of the mantle. As the planet cools, slabs sink, and continents drift, the landscape continues to evolve. You are witnessing an ongoing story, a testament to the ever-changing nature of our Earth. Would you like to explore this fascinating journey further, or take a moment to reflect? The ever-changing nature of plate boundaries reveals just how adaptable and interconnected Earth's tectonic system is. You might find it fascinating that these massive plates can break into new pieces. Despite their size, they are not indestructible. When stress builds within a plate due to forces from the mantle or collisions with other plates, the lithosphere can crack and form new fragments. This process gives rise to new plates or microplates, each with its unique movement and boundaries. These breaks can occur both on continents and in oceans, leading to the formation of rifts, new spreading centers, or shifts in the direction of plate motion. The splitting of a plate can significantly influence volcanic activity, seismic hazards, and the long-term evolution of landscapes. Scientists are able to detect these emerging fractures by analyzing patterns of earthquakes, GPS measurements, and the alignment of volcanic features. The creation of new plates serves as a reminder that Earth's surface is still evolving. Even regions that appear stable can undergo profound changes over geological time. The fragmentation of plates adds layers of complexity to the global tectonic puzzle, showcasing the planet's ongoing transformation. Hidden among the larger plates are smaller fragments, known as microplates, which fit together like pieces of a puzzle. Isn't it intriguing to consider how dynamic our planet truly is? Imagine a world where the Earth's surface is not just a few massive plates, but a complex tapestry of smaller pieces, each playing a vital role. You might find it fascinating that these microplates occupy narrow zones, accommodating subtle shifts that larger plates struggle to absorb. They typically form in areas where stresses create intricate patterns of faults and fractures, such as near spreading centers, transform boundaries, or where multiple plates converge. Though they are small compared to continental plates, microplates significantly influence the behavior of our planet's surface. They can move in various directions and at different speeds, sometimes even rotating or sliding between their larger neighbors. By studying these microplates, scientists aim to understand how stresses are distributed across plate boundaries and why some areas experience frequent earthquakes. The existence of microplates highlights that Earth's lithosphere is not merely divided into a few large sections. Instead, it resembles a detailed mosaic with many smaller components fitting together like pieces of a vast geological puzzle. Take the Caribbean plate, for example. It is a tiny but independent traveler among the Earth's plates, nestled between the North American, South American, Cocos, and Nazca plates. It moves through a region rich in subduction zones, volcanic arcs, and transformed faults. The Caribbean plate exemplifies the dynamic nature of our planet, reminding us that even the smallest players can have a significant impact. As you reflect on these intricate movements, consider how they shape our world. Would you like to explore more about these geological wonders, or perhaps take a moment to rest? Imagine the motion of the Caribbean plate, a small but significant fragment of the Earth's lithosphere. Its movement forms a chain of islands that gracefully curve across the Caribbean Sea. Many of these islands are home to active volcanoes, fueled by the subduction of the ocean floor beneath the plate. As you explore this region, you notice that the Caribbean plate also holds deep basins, underwater plateaus, and ancient crustal fragments. These elements tell a story of a long and intricate history. The boundaries of this plate are alive with frequent earthquakes, a testament to its dynamic interaction with the larger plates that surround it. This independent movement reveals just how crucial even modest-sized fragments can be in shaping regional landscapes and the hazards they present. The beauty and complexity of the Caribbean region owe much to the steady journey of this tiny traveler. Now, shift your focus to the Nazca Plate, which plays a pivotal role in the formation of the Andes. As it subducts along the western edge of South America, one of the most dramatic geological processes on Earth unfolds. The Nazca Plate sinks beneath the continent, generating immense pressure that folds and uplifts the crust, giving rise to the majestic Andes Mountains. As this oceanic plate descends, it carries mineral-rich water deep into the mantle, where it contributes to the creation of magma. This magma rises, feeding the volcanoes that dot the mountain chain. The interaction between the sinking slab and the overriding continent leads to powerful earthquakes and a constant reshaping of the landscape. Isn't it fascinating how these geological processes connect and influence one another? As you reflect on these movements, consider the intricate dance of nature that shapes our world. If you feel inspired, take a moment to continue exploring or simply pause to appreciate the wonders around you. The Andes stretch for thousands of miles, showcasing some of the highest peaks outside the Himalayas. Their rocks tell a story of ancient collisions, volcanic eruptions, and the thickening of the Earth's crust. The relentless movement of the Nazca Plate ensures that the Andes are always evolving, slowly rising and shifting as one tectonic plate dives beneath another. This constant interaction reveals just how interconnected our planet's surface is with the powerful forces that lie beneath. Now, let's turn our gaze to the Mariana Trench, the deepest known point on Earth. Located in the western Pacific Ocean, it feels almost like a boundary between different worlds. Here, the Pacific Plate bends downwards beneath the Philippine Sea Plate, creating a vast chasm that plunges over 6 miles below sea level. This narrow arc of darkness is under immense pressure, where sunlight never penetrates, yet life persists in this extreme environment. Organisms have adapted to thrive in the depths, feeding on nutrients that drift down from above or emerge from chemical reactions on the seafloor. The trench is part of a larger subduction system, which fuels volcanic arcs, deep earthquakes, and extensive chains of underwater mountains. As you reflect on these incredible geological features, consider how they connect us to the very forces that shape our world. Would you like to explore more about these fascinating phenomena, or perhaps take a moment to rest? The contours of the trench reveal the angle of the descending slab, offering insights into how oceanic crust ages, bends, and ultimately sinks into the mantle. The Mariana Trench serves as a reminder that beneath the surface of the Earth lie vast realms that remain largely unexplored. Tsunamis begin when seafloors suddenly shift. While they are often envisioned as colossal walls of water, their origins are rooted in subtle and unseen movements deep beneath the ocean's surface. In subduction zones, stress accumulates as tectonic plates press against each other until the seafloor abruptly slips. When this locked segment of the plate gives way, it can lift or drop large sections of the ocean floor in an instant. This displacement pushes immense volumes of water upward, generating long waves that travel across the ocean at remarkable speeds. In deep water, these waves are barely perceptible. However, as they approach shallow coastlines, they rise into towering surges, capable of reshaping entire landscapes. While volcanic eruptions, landslides, and even meteor impacts can also trigger tsunamis, the sudden shifting of seafloors remains one of the most prevalent causes. Scientists diligently monitor subduction zones, employing seismic and ocean sensors to detect these events as swiftly as possible. This ongoing research helps us understand the hidden dynamics of our planet and the forces that shape our world. Tsunamis reveal the deep connection between the ocean's surface and the hidden movements of tectonic plates beneath it. Picture the elegant curves of island arcs that grace our oceans. When one oceanic plate descends beneath another, it often gives rise to a stunning arc of volcanic islands. This happens as the sinking slab releases water into the mantle, promoting melting that generates magma. This molten rock then rises, forming volcanoes at the surface. Over time, these volcanoes can grow tall enough to break through the ocean, creating sweeping chains of islands. The shape of these arcs mirrors the geometry of the subducting plate, bending into the mantle like a great ribbon. Island arcs, particularly those in the Pacific, are vibrant ecosystems filled with lush forests, active volcanoes, and deep ocean trenches that trace the outline of the sinking slab. Their curved forms narrate a story of movement, pressure, and the complex processes that continuously reshape the ocean floor. These arcs are alive with activity, where earthquakes, eruptions, and the formation of new islands occur in harmony as part of a single interconnected system. Volcanic arcs can evolve into towering mountain ranges, beginning their journey in the ocean as subduction creates magma along a curved path. Isn't it fascinating how these natural phenomena work together to create such breathtaking landscapes? You are invited to explore and reflect on the wonders of our planet, or perhaps take a moment to rest and absorb this incredible story. As time flows and continents shift, volcanic arcs may eventually collide with larger land masses. When this occurs, these islands merge with the continent's edge, creating layers of new crust that can rise into massive mountain ranges. Some of the most breathtaking mountain chains in the world are remnants of ancient volcanic arcs, long since bonded to continental edges. These collisions not only add material to the crust, but also thicken it, leading to further uplift. This process can ignite new melting episodes, fueling additional volcanic activity that shapes the evolving landscape. Over millions of years, erosive forces carve these mountains into rugged peaks and deep valleys. The origins of these ranges are often etched in the chemistry of their rocks, which carry the distinct signatures of volcanic arcs that once emerged from the sea and transformed into towering landforms. Within many continents lie the remnants of these ancient arcs. Hidden in the bedrock are fragments that formed long before humanity walked the earth. Once, they stood as island chains above subducting plates. Over countless years, they drifted toward the continents, fusing into their edges. Isn't it fascinating to think about the history embedded in the earth beneath our feet? As you explore these mountainous landscapes, remember the ancient stories they hold. Geologists uncover the secrets of the earth by identifying rocks that bear chemical signatures from volcanic arcs. These rocks tell stories of ancient volcanic flows, ash layers, and intrusive bodies that once cooled in long-lost island environments. Some fragments come from deep-sea sediments that were trapped and uplifted when the arc collided with continental land masses. These preserved remnants offer insights into the history of oceans that have vanished and the epic journeys of tectonic plates. They reveal the timeline of when continents expanded through accretion, when they collided with neighboring land masses, and how mountain ranges formed. The presence of these ancient arcs illustrates that continents are intricate mosaics, woven together from many earlier worlds across vast stretches of time. Consider the Himalayas, where rocks that once rested on ocean floors now tower majestically. It may seem incredible when you stand before their towering snowy peaks, yet some of these rocks were once part of ancient ocean basins. As India drifted northward and collided with Asia, the ocean floor between them became trapped and forced upward during this monumental compression. These rocks experienced folding, crushing, and lifting to heights far above sea level. Today, they manifest as sequences of marine sediments, basaltic crust, and fragments of deep ocean minerals, all nestled within the highest mountains on Earth. As you contemplate these geological wonders, you might feel a sense of connection to the dynamic history that shaped our planet. You find yourself captivated by the majestic presence of the Himalayas, a testament to the monumental convergence of continents. As the land ascends, once horizontal layers twist and fold into intricate patterns, revealing the violence and persistence of this collision. These uplifted oceanic rocks serve as rare evidence of ancient seas that vanished as land masses collided, reshaping the entire region. Imagine the Alps, which rose from the remnants of a closing ancient sea. Long before these towering peaks dominated Europe, an ocean existed between the plates that would eventually form this iconic mountain range. Over millions of years, that ocean gradually narrowed as the African plate shifted northward, pushing sediments and crust toward the European continent. Eventually, the ocean closed completely as Africa continued its slow advance. The pressure from this collision forced the seabed upward, folding its sediments into the rising Alps. The rocks within this range tell a story etched in layers of limestone, shale, and metamorphic minerals once buried beneath deep waters. As the collision persisted, the crust thickened and the mountains soared even higher. Glaciers later carved the dramatic valleys that now define this breathtaking landscape. The Alps stand as a powerful testament to the closing of an ancient sea and the immense force of tectonic plates converging in a long, patient embrace. Take a moment to reflect on this incredible journey of the Earth and perhaps allow yourself to linger in this awe-inspiring narrative. Imagine a time when Greenland was not the isolated island we know today. Long ago, it was much closer to Europe, possibly even connected to parts of Scandinavia. Geological evidence reveals that matching rock formations and ancient mountain ranges exist on both sides of the Atlantic, hinting at a shared origin before the ocean began to open up. As the mid-Atlantic ridge started to spread, Greenland drifted westward on the North American plate, while Europe moved eastward on the Eurasian plate. This gradual separation widened the ocean, creating the distance we see today and isolating Greenland in its current position. Scientists are tirelessly working to uncover the details of this ancient connection. They examine magnetic patterns, fossil distributions, and the ages of rocks to piece together the story of Greenland and Europe. The history embedded in these rocks serves as a reminder that coastlines and continents are not static. They shift and change over time, often in ways that would be unrecognizable on modern maps. Consider Antarctica, a frozen land now shrouded in ice and battered by fierce winds. It wasn't always this way. Once, it was home to lush forests and thriving ecosystems, a stark contrast to the barren landscape we see today. Isn't it fascinating how our planet's history is written in the rocks and landscapes that surround us? Imagine a time when Antarctica was not the frozen expanse we know today. It once thrived in warmer latitudes, where towering trees, vibrant flowering plants, and even dinosaurs roamed freely. Fossilized leaves, petrified wood, and ancient bones litter the land, telling a story of a lush world that has long since vanished. As Antarctica drifted southward on its tectonic plate, significant changes unfolded. Ocean currents and atmospheric patterns began to shift, gradually cooling the region. Over countless millennia, glaciers pushed forward, completely transforming the continent into the icy landscape we recognize now. The ancient forests and their inhabitants disappeared, leaving behind only geological remnants. These fossils remind us that the movement of tectonic plates can dramatically reshape continents, turning once vibrant ecosystems into desolate, icy deserts through a slow, relentless process. Consider the Atlantic Ocean, it was once a closed body of water, much like the Mediterranean Sea. Today, the Atlantic is a vast ocean that separates continents and influences global weather. However, it began as a narrow, confined space. Long before the deep waters took shape, this area resembled the Mediterranean, surrounded by land and filled with young, shallow seas that rested between slowly drifting continental plates. Isn't it fascinating to think about how these geological transformations have shaped our world? As you reflect on this, you might feel a sense of wonder about the Earth's ever-changing landscape. Thank you for joining this exploration of our planet's history. Feel free to continue your journey or take a moment to rest. Imagine a time when the Earth was very different. Over millions of years, the land masses on either side gradually drift apart. Tension builds, faults open, and molten material rises, hinting at the birth of an oceanic basin. As this spreading continues, a narrow seaway widens, eventually transforming into an expansive ocean that stretches across the planet. This shift from a closed sea to a vast ocean changes climates and guides the evolution of countless species. It reshapes global circulation in ways that still resonate today. If you look closely at modern coastlines, you can find clues of this ancient transition, matching rock layers and mirrored continental outlines tell a story of time. The Atlantic Ocean reminds you that even the largest bodies of water begin as small rifts, patiently expanding through eons. Then there's the Mediterranean Sea, a beautiful enclosed body of water bordered by continents and steep coastlines. Yet beneath its serene surface lies the last remnant of an ancient ocean known as Tethys. Once, this vast ocean stretched across much of the globe, separating enormous land masses long before our modern continents took shape. As Africa moved northward, colliding with Europe and Asia, Tethys slowly closed, leaving behind small remnants of its once sweeping expanse. Today, the Mediterranean stands as the most significant remnant of this vanished world. It invites you to reflect on the incredible transformations that have shaped our planet, reminding you of the deep connections woven through time. Would you like to continue exploring this fascinating journey, or perhaps take a moment to rest? Beneath the surface of the Mediterranean Sea, ancient ocean crust, folded sediments, and the roots of mountains tell a story of geological upheaval. Imagine a time when this vast body of water nearly dried up, severed from the Atlantic Ocean, leaving behind thick layers of salt, now hidden beneath the seafloor. Every coastline you see holds secrets of the transformation from a global ocean to a nearly enclosed sea. The Mediterranean acts as a glimpse into a world long past, one that has profoundly influenced the arrangement of today's continents. Consider how the movement of tectonic plates has shaped Earth's climate throughout history. This slow drift of continents impacts climate more significantly than many other natural forces. As these plates shift, they alter the courses of winds and ocean currents, leading to changes in global temperatures and precipitation patterns. When continents gather near the equator, they can trap heat, creating warm and humid climates. Conversely, as they move toward the poles, they can foster colder conditions, even encouraging the formation of ice sheets. The dynamics of oceans also play a crucial role. The opening or closing of oceanic passages can change how warm waters circulate, sometimes cooling entire regions while warming others. Additionally, the formation of mountains through tectonic collisions can redirect airflow and influence how moisture moves across the landscape. As you reflect on these intricate connections, take a moment to consider how the Earth's history continues to shape the world around you. Feel free to pause and absorb this knowledge, or continue exploring the wonders of our planet's past. Imagine a world shaped over millions of years, where the slow movement of tectonic plates creates a dynamic and ever-changing environment. This constant evolution influences the climate, ensuring that it is never static but always in flux, responding to the shifting contours of the Earth's surface. The arrangement of continents plays a crucial role in the onset of ice ages. Throughout Earth's history, long cycles of glaciation have been driven by how land masses drift toward the poles. These large expanses create stable surfaces where snow can accumulate year after year. As this snow compacts, it transforms into thick ice sheets that gradually spread outward. The presence of these ice sheets reflects sunlight, contributing to a cooling effect on the planet and reinforcing the glacial cycle. Additionally, when continents cluster in specific patterns, they can disrupt ocean currents that typically transport warm water to higher latitudes. Without this warmth, polar regions experience dramatic cooling, allowing ice to advance over vast landscapes. Geological evidence reveals that at various points in history, the arrangement of continents has favored global cooling, enabling ice sheets to expand across multiple regions. As you reflect on this intricate relationship between the Earth's surface and climate, consider how these ancient patterns continue to shape our world today. Would you like to explore more about this fascinating topic, or perhaps take a moment to pause and absorb what you've learned? As you embark on this journey through the vastness of our planet, you begin to understand that climate is influenced not just by the atmosphere, but also by the ever-changing geography beneath it. You discover that ocean currents, those vital highways of the sea, shift as continents drift. These currents weave through a complex network, carrying heat, nutrients, and life across the globe. You realize that the shape and position of continents play a crucial role in how these currents flow. When a continent moves to a new location, it can block existing pathways while creating new ones, drastically altering the movement of water. For instance, consider the formation of the Drake Passage near Antarctica. This change allowed a powerful circumpolar current to emerge, isolating the continent and contributing to its icy conditions. You reflect on how the opening of the Atlantic Ocean transformed the flow of warm water from equatorial regions, significantly shaping the climate of Western Europe. As continents drift apart or collide, narrow seaways can expand into vast oceans or close entirely, redirecting currents into new patterns. These fluctuations have profound effects on global climate, marine ecosystems, and weather systems. Each shift in ocean circulation serves as a reminder that plate tectonics orchestrates the rhythm of our oceans. You uncover that some continents once resided near the South Pole, and the continents you recognize today have not always held their current positions. As you contemplate these changes, you might feel a sense of wonder about the dynamic nature of our planet. Would you like to continue exploring this fascinating topic, or perhaps take a moment to reflect? Throughout Earth's history, massive land masses have journeyed into the cooler southern latitudes, spending extensive periods near the South Pole. The evidence of this icy past is found in glacial deposits, striated rocks carved by ancient ice sheets, and fossils of cold-adapted plants that once thrived near the edges of enormous glaciers. Remarkably, entire continents carried these glacial marks before drifting back toward warmer climates. These movements of continents through polar regions have instigated significant climatic events, including eras when ice enveloped much of the planet. This exploration into our planet's past reveals that even the warmest areas we know today might have once been frozen landscapes. The wandering paths of continents across latitude lines have not only transformed global climates, but also help us understand the dramatic climatic shifts recorded in rocks. Plate tectonics plays a crucial role in shaping where animals and plants evolve. As continents drift, they create new environments, isolate populations, and open pathways that guide the evolution of life. When a continent splits, species become separated and begin to evolve independently, often resulting in entirely new forms. Conversely, when continents collide, land bridges can emerge, allowing species to migrate into new territories and interact with existing ecosystems. Take a moment to reflect on these incredible journeys of our planet. Each movement tells a story of transformation and adaptation, shaping the diverse life we see today. If you'd like to continue exploring this fascinating topic, feel free to stay with us or take a moment to pause. Mountain building events create new habitats with diverse temperatures and elevations, encouraging species to adapt in fascinating ways. The movement of tectonic plates also influences climate, which affects where plants and animals can thrive. Over millions of years, these changes have shaped the distribution of life across our planet. Many unique species found on isolated continents trace their origins to long periods of separation caused by plate motion. Plate tectonics is not merely a physical process, it serves as one of the great architects of biodiversity, guiding the rise and spread of life in countless ways. Fossils reveal ancient connections between continents. Long before the theory of plate tectonics emerged, scientists observed striking similarities between fossils located on continents now separated by vast oceans. Identical species of ancient plants and animals have been discovered in distant places, suggesting that these lands were once connected. For instance, fossils of the reptile Mesosaurus appear in both South America and Southern Africa, yet this creature could not have swum across an entire ocean. Additionally, fossilized plants from the coal-forming forests of ages past show up on continents that are now far apart. These intriguing puzzles provide early clues that continents have drifted over time. Isn't it fascinating how the Earth's history unfolds through these discoveries? As you reflect on this, consider how interconnected life truly is, shaped by forces beyond our immediate perception. You might feel inspired to explore more about the wonders of our planet's past. Today, you explore the fascinating fossil patterns that help reconstruct ancient supercontinents, illustrating how land masses once merged into larger forms. Fossils serve as a biological map of Earth's past geography, revealing that life once roamed freely across regions now divided by vast oceans. They uncover a world radically different from our own, shaped by connections that have long since vanished. Consider the geological similarities between South America and Africa. The eastern edge of South America and the western edge of Africa fit together seamlessly, like two pieces of an ancient puzzle. Beneath their shorelines, you find matching rock formations, mineral deposits, and mountain structures that indicate these continents were once united. Identical layers of sandstone, volcanic rock, and ancient sediment exist on both sides of the Atlantic. The fossils preserved within these rocks tell a story of the same plants and animals that thrived across a single connected landmass. As the Atlantic Ocean began to open, a rift tore this shared landscape apart, leaving behind mirrored geological features on opposite continents. Even today, scientists rely on these clues to trace the ocean's expansion and the spreading of the mid-Atlantic ridge. The geological connection between South America and Africa stands as one of the strongest pieces of evidence for continental drift, illustrating how the world has been reshaped over immense stretches of time. As you reflect on this remarkable journey through Earth's history, take a moment to appreciate the intricate connections that once existed and continue to inform our understanding of the planet. Would you like to delve deeper into this fascinating subject? Or perhaps take a moment to rest? Imagine a time when India raced northward, faster than any other continent in history. This remarkable journey began when it broke away from the ancient supercontinent, Gondwana. As it embarked on its swift trek across the Earth, paleomagnetic measurements revealed something astonishing. India moved at a pace far beyond typical plate motion, propelled by powerful forces from beneath. Eventually, this rapid movement led to a monumental collision with Asia. The impact was so intense that it gave rise to the majestic Himalayas and uplifted the Tibetan Plateau. The rocks in this collision zone still bear witness to the staggering compression caused by India's arrival. This journey did more than reshape the landscape. It altered global climates and transformed ocean circulation, redefining the geography of an entire region. India's swift passage through time stands as a testament to how even massive land masses can behave unpredictably under the influence of deep mantle forces. This collision between India and Asia is one of the most dramatic examples of continental motion in Earth's history. When India reached the southern edge of Asia, it not only reshaped the region, but also left a lasting mark on the entire planet. As you reflect on this incredible story, consider the forces at play in our world. Would you like to explore further, or take a moment to absorb this fascinating journey? Imagine the powerful forces at work beneath the Earth's surface, where continents collide and reshape our world. This monumental clash creates the Himalayas, one of the tallest mountain ranges on the planet. As India pushes against Asia, the Tibetan Plateau rises, forming a vast elevated landscape that significantly influences weather patterns across half the globe. This collision doesn't just change the landscape, it alters atmospheric circulation. Jet streams shift, and seasonal winds gain strength. Ocean currents are redirected, impacting moisture delivery and shaping the monsoon cycle that sustains billions of lives. The uplifted terrain exposes ancient rocks to erosion, drawing carbon dioxide from the atmosphere as they weather. Over time, this process cools our planet, demonstrating how a single continental collision can affect climate, ecosystems, and the balance of life for millions of years. The Himalayas do more than rise majestically. They act as a formidable barrier that directs winds and moisture across Asia. When warm, moisture-laden air flows northward from the Indian Ocean, it meets this towering wall of mountains, forcing the air upward. This interaction plays a crucial role in the region's weather patterns. As you reflect on these natural wonders, consider how interconnected our planet truly is. The Himalayas serve as a reminder of the profound impact that geological forces have on our climate and environment. Take a moment to appreciate this intricate dance of nature, where mountains not only reach for the sky, but also shape the very air we breathe. If you wish, you can continue to explore these fascinating processes, or take a moment to rest and absorb this knowledge. As the sun rises, the air begins to cool, releasing moisture and giving way to the intense rainfall that characterizes the South Asian monsoon. Imagine a world without the Himalayas. The monsoon would be significantly weaker, leading to dramatic changes in the climates of India, Nepal, Bhutan, and the surrounding areas. These majestic mountains play a crucial role in global wind patterns, redirecting the jet stream and influencing the distribution of atmospheric pressure systems. The Himalayas are not just a geographical feature, they act as a vast atmospheric engine. They guide storms, shape seasonal changes, and control the timing of rains that are vital for agriculture. Their presence is essential for sustaining entire civilizations, transforming the collision of continents into weather patterns that nourish life. Now consider the phenomenon of deep earthquakes. They occur where tectonic slabs bend into the mantle, often far beneath our feet. While most earthquakes happen close to the Earth's surface, these deeper quakes can originate hundreds of miles down in areas where subducting slabs descend into the mantle. Scientists believe these deep earthquakes are driven by unusual processes, such as transformations within minerals that release sudden bursts of energy, or the rapid movement of fluids within the slab. Take a moment to reflect on the intricate connections between our planet's geological and atmospheric systems. The interplay of these forces shapes not just our environment, but also the lives of countless people. As we continue to explore these wonders, we invite you to pause and absorb the beauty of our world, or perhaps take a moment to rest. As the descending tectonic plate is compressed and heated, its minerals undergo a remarkable transformation. They rearrange into new forms, which can lead to sudden shifts beneath the Earth's surface. These quakes travel through the mantle, offering valuable insights into the structure of these sinking slabs. Although they occur far below, where they are unlikely to cause surface damage, they provide a fascinating glimpse into a realm filled with crushing pressure and intense heat. Here, the behavior of rock is vastly different from what we observe at shallower depths. Some earthquakes happen hundreds of miles beneath our feet, at depths that challenge our understanding. These seismic events occur in conditions where temperatures and pressures are so extreme that rocks should deform gradually rather than fracture. Yet seismic instruments capture sharp jolts of energy from these deep regions, sometimes originating nearly 400 miles below the surface. At such depths, minerals transform into denser forms as they are subjected to immense pressure. This transformation can release energy in sudden bursts, behaving much like earthquakes. Some scientists propose that fluids trapped within these slabs may trigger deep movements as the plate warms and dehydrates. These deep quakes not only help map the sinking slabs, but also reveal their shapes as they descend into the Earth's interior. Isn't it intriguing to think about the hidden dynamics beneath our feet? Each quake offers a chance to understand the complex processes shaping our planet. Would you like to continue exploring this fascinating world, or perhaps take a moment to reflect on it? You might find it fascinating that Earth is constantly active, even at depths far beyond our reach. The processes that shape our world extend deep into the hidden interior, where rocks behave in ways that can be quite mysterious. One of the intriguing phenomena you might encounter is known as slow slip events. These events remind us that not all tectonic motion manifests as sudden, violent earthquakes. In certain regions, faults move gradually over days, months, or even years, a phenomenon scientists refer to as slow slip events. During these episodes, the surfaces of faults slide past one another at a pace so gentle that it's not detectable as shaking by human senses. You may wonder how we know about these subtle movements. Seismic instruments pick up faint signals, while GPS stations track small but